Hey guys, welcome back. Alright, so we're working on the car and we purchased this little guy. So this is only like 10 bucks or 20 for two of them. So this is a buck converter. So you feed it voltage, it does some magic, and it outputs a lower voltage. And this one has a constant current and constant voltage output. What are we going to do with it, use this for? Well, we don't know yet, but I have an idea. So my idea was, so I've got a 17 volt battery, and it's our 16 volt, but it's going to run 17 and a half volts when it's fully charged. So my question was, could I drive, for example, the cooling fan at a lower voltage, maybe as like a low setting or a medium setting or something, to where it's not running at like 17 and a half volts? Because if I actually do that like a lot, it's going to be super loud and, probably bad on the fan and completely destroying my battery state of charge. So I purchased this little guy. I haven't even powered it up yet, but I want to try it out and get the voltage adjusted and then see if it'll actually run a fan. And if it does, we may rig up a little system in the car to allow it, like if you put the fan in auto, to where it could like flip a couple of relays and change voltages to give us different fan speeds and conserve electrical energy and not be so loud and keep our battery charge high. So let's see what happens. Okay, so step one is to plug it in and turn it on. Looks like we got to plug in our power supply. Okay, round two, power supply on. Hey, we got voltage. Okay, well, something's happening. Let's check our voltmeter and see what we got. Oh, looks like this. 4.6. Well, that's actually not too far from what we wanted to test. So let's try that. See what happens. So, let me show you guys. Using a tripod as a recommendation from one of my subscribers. So down here, under this table, is a pair of electric fans. So, and I got them wired up to my bench. This is to put a load, a bench load, like an inductive load. I was doing some testing a while back on a system that didn't work. So it's still hooked up. Anyway, let's hook this up, see what happens. Okay, no fans. Oh, let's see if we can get a voltage reading while we're doing this. This will probably be difficult. Alright, I'll bring you guys back. Let me get set up. Okay, we'll try this again. Let's see if we can film this. We touch our wire. We're dropping to like half a volt. Okay, so I'm going to adjust. I'm actually only feeding this circuit like 8 volts. Don't know if that matters, but I'm going to go ahead and bump that up all the way to 15. So now we got 15 volts going into this. Let's see if that makes any difference. What happened? So we're getting like 1 volt. Roughly. So I don't know if the fans are actually turning. Let me check that on my own. Oh, they are. Barely. Okay, so that actually worked, but it's folding back. So my guess is that we got to adjust our constant current to a lot higher, because we're set at 12 volts right now, and that's interesting that changed when I changed the supply voltage. That's not really a good sign. But let's turn our constant current up and see if we can get this to perform at all. Alright guys, so we've been working on this a little bit. We got it working. We had to adjust our constant current, constant voltage, but it seems to be working fine now. So you can see the voltmeter. We've got that sitting right at about 6 volts approximately. And we're going to reach over here and touch the fan, see what happens. See it dip a little bit. Hold on. There we go. Dips a little, fan comes up, and we're still sitting at about 6 volts. And we disconnect the wire, 6.02. So this is working. Fantastic. A little bit of warmth, nothing crazy. So, and that seems to give us some airflow. It's not like ripping, but that's what we're going for. We're just trying to get some airflow. This is probably, I'm not testing with the real fan on the car. I'm just testing with some fans under the bench. But actually, let me show you. Hold on. Okay, so this is like your big equation for doing pretty much all your common electrical stuff. So if we look here, this is power. All three of these equations are relevant, but let's use this one. Power is equal to V squared divided by R. V is voltage, R is resistance. So the fan's resistance doesn't change, but if I change its voltage, its power that it's going to consume goes up with the square of the voltage. So what does that mean? Well, if I go from 6 volts to 12 volts, it doesn't just double the power, it's going to go up by a factor of 4. So if I was pulling 50 watts at 6 volts, when I go to 12 volts, instead of 50, it's going to be 200. It's going to be 4 times that. And that's why backing the voltage off makes a huge difference in power consumption. So we got to do a little testing to make sure this thing's durable and that kind of stuff. May need to cool it. We're going to have to mount it somewhere. Got a little bit of details to figure out. But what I love about this, the engineer in me is just dying to wire this up for the water pump and the fan, because if you've got a car that's like, okay, it's a drag car, right? I'm going to be going wide open for like, what, 10 seconds maybe? And then 97% of the time, I'm not doing that. So basically the 97% of the time I'm not doing that, I can slow down the water pump and slow down the fan, conserve battery power, not wear all these parts out. So it's kind of a win-win situation. And then just kick them up when I need them. Or, you know, if you're trying to cool down or, you know, whatever the case. So I think we're going to sit down and design a little circuit. But anyway, this is the promising part. And what I like about this, if it proves to be reliable, is this is simple. This is like $10. And I probably just need a couple relays to, depending on what level of complexity I put into this, to implement. So anyway, let's take a look at that and see what. Okay, I got to show you one thing that gives me hope. So look at this voltmeter, 5.995. Now this is my bench power supply. I can change the voltage. So if you look here, we can see we're just above 8 volts. But if I grab this knob, this knob, I can turn the voltage all the way to about 15 volts. Let me show you something. I'm going to back this all the way to 8. Here's the voltage coming out of our fan, or out of our circuit. I'm going to go all the way to 15. Watch what happens. Here we go, 15 volts. That changed by 1/1000th of a volt. 1/1000th. Wow, that's impressive that it can actually, that's really impressive. It's holding it within 1/1000th of a volt. And I just basically went from 8 to 15, so I almost doubled the input voltage. So what that tells you is we're not sensitive to the battery going up and down a little bit. That's not going to affect this. That's fantastic. That's actually a pretty good sign that there's a little bit of thought went into the design of this. Kind of amazing. Anyway, on and upwards. All right, guys. So we're going to do another test. So I actually have 2 of these power supplies. So what I've done, we've still got this one set up for 6 volts. But what I put an amp meter in line. So now when power comes out of this meter, it can go through the amp meter and I can see how many amps are feeding it. So what we've done, this new one, I have the grounds tied together and I've set it up for 7 volts instead of 6 volts. Now, what I'm hoping happens is that whenever I turn this supply on, all of a sudden the fan is going to run on 7 volts instead of 6 volts. Yeah, hold on, this thing's... Anyway, there we go. So what should happen is when this goes to 7 volts, the amps on this one should go to 0. So basically it's not doing anything. That's because these are buck converters. So what happens is voltage comes in, it goes to these caps, these FETs over here, here, and here. These switch power into this inductor, which then dumps it into these caps. So if the voltage gets too high, it basically just quits switching this and quits adding voltage. So it shouldn't hurt to run the voltage up within the limits of the FETs. So we're going to try this. I think it's going to work, but if it doesn't, it'll make an interesting video. All right, so we're going to flip this on, and let's see what our amps are. And remember, this is 6 volts. So I saw it spike to 9. Now the amps are settling because the fans are coming up to speed. Looks like we're just over 4 amps, like 4.1 amps. It's okay. So let me show you just power-wise, because like I said, we slowed the fans down. So if we do our volts times our amps, just from looking at our graph, P is equal to V times I. Volts and amps, so 6 volts and 4 amps, or 4.1 amps, whatever. 24 watts, 25 watts. Yeah, not very much power. If this was running on 12 volts, that'd only be 2 amps of draw. So, pretty incredible. Now, granted, these aren't the fans that are going on the car, but trust me, those fans pull a lot of amps when you get the voltage up. So, that's why we're doing this. Alright, so here's the test. We're pulling 4 amps. If I'm right, this wire here is looped in after the current meter. So what I expect to happen is that when I touch it to the supply over here, my fan should speed up and go to 7 volts, and this current meter should go to 0. Or something explodes, but I think it's going to work. Let's try it. Alright, getting ready. Here we go. Touch. I heard the fan speed up. Our current meter went to almost 0. So it seems to have worked. So let me disconnect it. Yep, that did work. I heard the fan slow down. Maybe y'all can hear that. Let me try to make that a little better. Hold on. Okay, so what I did was I just turned this up to 10 volts and I turned off my little fan over there so it's a little quieter. Let's do that same test again. We're going to touch that wire, and this time we should see our amp meter go to 0, and you should audibly hear the fans speed up. Alright, here we go. Okay, that definitely worked. I'm going to put the camera by the fans. That's running on 6 volts. Go back to 10. Oops. So, actually, let's check something else. So we can see it's pulling 4 amps. We did the math on that. So now, all we got to do, loop it on this one. So now we're looped on the other wire. So since we're at 6 volts now, it still shows 0. Now when I hook it to the other supply, it's going to jump up, and we should see more than 4 amps, a lot more. Probably, let me just estimate, it's probably going to go from, like, probably more than double, but let's see. There we go, a little more than double, 8.3 amps. So now we're running at about 10 volts and 8.3 amps. So let's look at that. 10 volts times 8.3 amps, 83 watts. So we can see just going from 6 volts to 10 volts, we went from 24 watts to 83 watts. Big difference in power consumption. Of course, granted, the fans move a lot more air when you give them 10 volts, but you see my point. If we were to keep going up on the voltage, which this supply, my supply here will only go to 15 volts, so this little guy is only going to go so high, probably like 13 volts before it tapped out. But the point is, if I kept turning that up, the amps are going to go up, the volt's going to go up, the power's going to go way up. So that's why we're doing this. We can set this up. Now we know that this is compatible. We can just feed one into the other. It's not going to hurt it. So this makes it easy. Now the wiring is just, like if we only did 2 speeds, you could just do a single relay. Well, or whatever, maybe a switch and a relay, but it wouldn't be very complicated. We'll probably make it complicated because I can't help it, but anyway, hope you guys see the point. So I think this is pretty cool. This is going to help us out since we're running on batteries all the time. Being able to build a circuit like this is going to be able to save a ton of battery power. Like you can see now, if I go, say I go drag race and it takes like, 10 minutes to, crank the car, idle, drive around to the starting line, do your burnout, make a pass, I may only need that fan to run at full speed for say, maybe a minute. Let's just say 1 minute. It's probably being, that we probably don't even need that, but let's just say a full minute out of 10. So that's, let's say the fan, I think the one on the car pulls 15 amps. So 15 amps, well, that's actually at 13.8 volts. It's going to be running way higher than that. It's probably going to pull 20 amps if we feed it 17 volts. That's 340 watts of power. Now, if we can knock that down and only pull, let's just say 5 amps at 6 volts, 30. So that's, 10%, going from 340 to 30. So you can see the difference. If we can take like 90% of the time, instead of pulling 300 watts, we're pulling 30, well, that's going to make our battery last 9 or 10 times longer than it otherwise would. And that's why we're doing this. So we're going to do that for the fan and the water pump at this point, as far as I can tell, because it looks like this works and it's cheap and easy. So anyway, hope you guys have enjoyed this little electrical engineering project, but I think it's going to be worth it. The hard part now will be probably the packaging, because these things get warm and they're not really that hot, but they're going to need to be in an enclosure, and we may put a fan on them for reliability. Anyway, hope you guys have enjoyed this, and Till next time, y'all take it easy.